granularity. So here we wanted to compare granularity, all right, to see, how detailed that it would be, right? Granularity. So one is object-oriented, and the other, we always compare these two. The other, that's relational database. All right, so as table, right? Table and here we have object, right? So granularity is the extent to which a system can be broken down into smaller pieces. All right. So which one has a higher granularity than the other? Which one is higher granularity than the other? Things TA probably has already talked this issue, right? So you have already described this part. Penny, granularity. Do you want to say that? So granularity can go to that, smaller pieces, broken it down to smaller pieces. We can break down to smaller pieces. Okay, Harry.
Sorry, but I want to ask a question. Is your question is what is granularity, or
No,
which part is granularity is more harder, or what?
high granularity.
In this diagram?
No, I asked not in this diagram, but talk about the relational database and object-oriented.
Can you speak slower?
Object-oriented and relational database, we compare these two, right? It's a mismatch. So regarding granularity, right? Granularity, object-oriented is a higher granularity or relational database. This is that.
Let me think.
You can answer this question. This is very hard. So then would you explain this concept?
I think object is more higher granularity because, for example, person can maybe break down, person can have maybe address and order. So that is the smaller part. So I think object can have more higher granularity.
You said that, and then I'm going to ask you, relational data, so we have person, we have order, we have address table. Yeah, different table. And we link them, right? Like this. Then they are the same. So you have person, right? This is different, right? So we have table, person, we have order, we have address. They are the same. So when you said that's higher granularity, which part? So here it says granularity is the extent to which a system can broken down into smaller parts. So now here, give us an example that person could be a table, right? Third table, and here that is a class. So person has address, right? Is this a composition? Person has address, and person's a relationship to order, and another bit in detail, right? But when we change to relational database, it seems not difficult at all. They are the same. What does it mean here? That object higher granularity. The different, right? Different classes, a different table. So we talk about similar thing, right? We talk about similar thing. No. Yes, Harry?
I think object-oriented is more high granularity, because object-oriented will make system to different small class, and the class only have do one things, or so do things, or is more sparters, and the relation database is different tables, but the tables maybe is more attributes and behaviors to how to say
So it's a relational database as a behavior.
no, it's not I mean my means is more like object oriented is more the spirited
It says it contain more data.
more
database.
like only do one things, and
But then, okay, if that is text, all right, we have a table, text rates, right? State and text rates, only this. It's only text rates, right? And here, person is just one data, right? Everything that's related to person, right? And we go to relational table, the table related to person. If text, you know what it means, or it's a zip code, right? It's a table. It's only zip code. It's a table, all right? So it could be lots of data. It could be, you know, a little bit of it. So they're quite similar. How come we said that granularity? So from this diagram, we can convert it to relational database. So Tim, can we convert it to relational database? Almost the same. We have 4 tables, right? So then so why you wanted to answer this? Table could be very simple. Table, look up simple. Look at table, right? Zip code. Text rate. Look up table, right? It's very simple, right? But here, person, what do you consider a class? Person, I mean, not that simple, right? So it seems similar. So let's take a look at a person, right? A person, it is a table. So I said that person has many address. So we create another table. We give it a name, address, right? So person is, we are not allowed to have multiple value for address. So we create address table. And here, person, and we think that address, this class, right, is better to become a class, not an attribute, because address will be used by others. So address, we create another class. So for this, they are similar. It's like broken down into smaller parts. Person and order, they are the same, right? We create order table. And here we have persons wanting to order something. So person to order, that's one to many, right? A person wanting to order zero to many, right? Zero to many. If a relational database, a person wanting to order, right? Order something, right? So a person can order many things. So we use key, right? If order, that's an order number. We have order date. We have amount. We can see that if here the order item, then we take it out, because order item, can be many. Order item and description like that. So then we can expand its order, right? And here, since object-oriented allows for multiple value, so there's no problems of it. So what would we see that granularity? You got a concept or a hunch to answer this? They are the same here for this part. Yes, Penny?
Is your question is, do I understand the granularity? In my opinion, my granularity is if your table, in relational database, in your table you have so many data, like address cannot be in the person, so you take it out into a small parts. It's like that.
If you wanted to cut it, break it into smaller pieces, then yeah, you can go to very, very small pieces, and yes, the granularity will be very high.
Oh, so you take more items out and make it a table so many, then it is a high granularity.
That is what it says. Granularity extend that, so we can broken it into smaller pieces.
Okay.
So you are not going to answer question. You are.
What is the question?
Which one has a higher granularity?
Object or database?
Object or relational
Oh,
table?
I think it's relational database.
Okay, why is that? Anything that's relational database has, but you cannot see in object-oriented about granularity. You cannot expand it, right? Which one can expand more? You can expand more, that's a higher granularity. Tell me that which one that's is a relational database, right?
Oh, so it's object because it can know many things in objects, but in database it's only the raw. It can describe so deep.
So deep. So deep.
Yes.
So it says a relational database has many. Well, it said the object has many items.
Yes.
A relational database has many attributes. A record. So since we said that a person can transfer to a table, right?
Yes.
Then tell me which one that relational database can, go to very smaller pieces, but object cannot. On the other way, object can go to smaller pieces, but relational database cannot.
The relations performed is after is more better, like aggregations or associations like that. In objects, it's more visible and
Object is more
visible,
visible,
more clearly.
clearly. But here
Yes.
it's not clear now. It says we can grind it, to smaller pieces.
Yes.
So object has, if the object has aggregation, here aggregation, right?
Yes.
Aggregation. So object here has aggregation. What about relational database?
Relation database, it will have two table is person and address, and person has FK in address PK. Person has FK, it's a name, address, ID, or
So they can do
what?
it. So you can do it, right?
Yes. So
It's a good answer, right? So good try, yeah. So here, does anyone wanted to describe this granularity? Yeah, Shan.
The granularity, the first, I think object-oriented database more granularity than relation database, because like like an example, the image on the address and the person, like the address of the person. In this case, maybe address is not a list. It's only one person only have one address. In this case, in the oriented database, it will use the address class to present address. And in the relation database, the address will put into the person and only have person
Not
table.
necessary. Address can be a table. Right. Let's talk about that. Address. If customer has many address, so address become a table.
Yes, but that is only when the address has mutable, but the address, if only one, it will put in the person, and maybe have the same thing like this. So if the thing only have one, the relation database should merge to the same table, but the oriented database didn't. Only if the attribute about no, if the same thing like address or maybe the 1 to, if the thing is 1 to 1, it also can have a class to store this.
Okay, that's a pretty good answer, right? You can see that. So here, that yeah, it's good. So like Penny says deep, but Penny did not explain that deep, right? Go deep. So here, but the concept that is encouraging to think about deep, right? So action is that, well, here, person, this is object oriented, so person has address. We use composition or aggregation, right, to express that. So it's visible, right? So it's a Penny said, right? It's quite visible. Then we understand their relationship very clear, right? So clear, and no matter what address, it could be only one address. So Shen says, if person has only one address, then it's included in person, right? So we will not subdivide that, right? But object-oriented, it doesn't matter, right? So we think that address will be reused by others, right? So that we can break it down. A lot of attributes, right? We can break it down to very small part, right? But we can see that probably our relational database, they only put it in the table, right? So table become the row, right? So it's a row, that's attributes in this table and row, just like that. So for granularity, we can go to very smaller pieces. So here, object has a higher granularity, so to the extent we can break it down to smaller parts, all right? Not because only multiple value, right? Break it down. If it is not a multiple, then usually we'll group inside the one table, right? So it's a various level, right? So it depends on our design. If we think that we can reuse it, right? So there is a level of granularity, and here relational table, right? Could be like that, right? It's just a two levels of granularity. Use key, right? So 2 levels. So think about that. Our object, we can go deep, right? Go deep. So for example, we have inheritance. Or deep it, all right? So it's more complex than relational database. Okay. And relational database only, you can see that and use key to link that. That's different. Inheritance, right? You can see go deep and their association with others that we inherit by the subclasses. Identity, what is that? All right. So if we said it's the same identity, object identity, that means, we double equal. They are the same. They should be the same. Come from the same address. But equal, right? It's only data, right? Data are the same. Association, right? So relational database then use key, right? It's foreign key to connect different table. But our object-oriented, then we can use this variable, right? Variable association, we know that we can use it, or we pass the parameter, right? So it's quite flexible for object-oriented navigation, right? So navigates. So here from this, go to the others, right? Navigation. We ask for help, right? So we pass the request to the neighbor, right? To the neighbor. So the load meter asks some neighbor, the neighbor to do it, right? Don't talk to stranger, right? That's for a relational table, right? Here you will use, if we want to navigate, we use key, or here is it, we want to query that. We need the data come from different table, all right? So here, this process will be very slow. And then the ORM, right? I said that if we wanted to transfer, right, convert it object concept to relational, right? So it is a mapping, right? So yeah, we call this object relational mapper, ORM, right? Different language might have different ORM, right? Like Django, here, this is like Python, right? Python use Django. Or our Java, right? Java will not use Django. Java will use which one? Java. Michelle, do you understand ORM Java use? Howard? Second time. Yeah, Shan.
JPA or JDBC?
No. It's a database connector, right? But we said that it's going to map to relational database, not JDBC. So it's ORM. Nobody. The words from H. Yeah, Harry.
I don't know how to speak like, but HIBERNATE, Hibernate.
Yeah, Hibernate. Yeah, it's a Hibernate. So Java use Hibernate. Serialization, deserialization, this is pack and unpack. Right, this is pack and unpack. Right, so it's like divide and conquer. Right, so we have that. We unpack it, deserialize it. Let's see the Hibernate. Let's see Hibernate. All right, we're going to jump to the. I think TA introduce this. If you go to tutor time, then you understand that someone will ask. Yeah, this part, participants table, how to convert participants, right? So the right hand side is a problem domain, right? So it presumes object-oriented concept. So if we wanted to convert, so this step by step, participants, So we need to convert participants to object-oriented, object relational database, all right? Yeah, object relational database. So here you can see the attributes. And one condition that we wanted to convert participants, right? So here, of course, our object relational database depends on our provenance domain, right? That means that we wanted to convert from participants to these participants. You don't need to have table the words. So what condition that we need to, conduct the mapping from participant to participants? What condition? Oh, you come here for what? Just come. So I need to explain this. Yeah. Okay. So we wanted to conduct mapping, right? Our provenance domains, participants. And participants here, you can see ORDBMS, right? Object relational database. We conduct the mapping, all right? So that is, a consideration about participants. So first question is participants an abstract class or concrete class? Participants here, a subclass, all right. Right. Do you understand that, participant? It's an abstract class or a concrete class? Only abstract, concrete. Yeah. So already, you come to the tutor. Yeah, and okay, explain that. Do you understand that? Concrete? Concrete. Harry? Oh, what?
I think participants is concrete class
It's a concrete class. How do you know it's a concrete class?
because the inheritance.
Inheritance. Not because inheritance is a concrete, right? Abstract class can have children, right? Parents not necessary to be concrete. So you think that inheritance, you say inheritance should be concrete. A parent should be concrete. You said that? So how do you know this?
Sorry, I think it is abstract because
Could be concrete or could be abstract, all right? So you're not going to say that it is concrete or abstract, right? So what if it's abstract or concrete? Right. Yeah, because we don't know. It's abstract or concrete. It could be abstract or could be concrete, all right? But when you say the inheritance can be concrete, then that would be not correct, right? Inheritance, the pattern could be abstract, right? Yeah. So here it could be abstract or could be concrete. Right. So what if it's abstract? And how many children you can see that you expect that participant, how many children?
one is patient and
One is patient and you say one, then it means others.
to this diagrams and only one children is patient.
It's only one child. But you think that it's only one child. So anyone can answer this. A participant could be, your participant could be abstract or concrete, right? You're not going to say that it is concrete or abstract, right? It could be either, right? If it is an abstract, if it is an abstract class, then should we convert it to object relational database or should not? Or it doesn't matter, it's abstract or concrete. Eric, what do you think? It could be abstract or could be concrete. So I'm going to say that it's abstract or concrete. Okay. Okay, anyone wanting to answer this? Participants, two participants. All right. So here we can see the mapping, right? Dotted line and the arrowheads. So of course, depends on what's the problem domain, right? So now we come to our participants. So participants, here participant. If participants is abstract, right? It is abstract, and it has more than one subclasses. So now, don't believe what you see, because it gives you only a fraction of that, right? So participants has subclasses, consists of patient, employee, and other, right? So we have different kinds of participant. In this situation, then we got to do the mapping, right? So participant is an abstract class. If participant is a subclass, the same, all right? So usually we wonder that if it's abstract, then do we need to conduct a mapping? Yes. This abstract class may have different kinds of subclasses. So actually, this situation, not just a patient, right? It's the thing, participant, it's many participants with doctor, right? with employee, with lots of it. All right. So here, this abstract class become very important. So we need to conduct a mapping, right? So the first step that we conduct the mapping. So the attributes. So what's the participant has? Last name, first name, address, phone, birthday, and derived age. All right. So you can see that. Anyone tell me, when we convert the mapping, how come it become different? So explain this after conversion. So why has to become not the same? Question?
We can see the edge is missing, and missing when you convert it.
No, here address here not missing address.
Edge, AGE,
Okay,
Age.
All right. Is
Sorry.
it oh,
and
mhm.
because the birthday birthday date can be converted to the edge. The edge is the same meaning of the birth date, but in the object relation database, you shouldn't store the
Derived-
value you can to calculate it.
Okay, that becomes a procedure, all right?
Yes, it's
Just
common
so-
procedure.
Okay, yeah, so here, this, because when you calculate, it's not a direct value, right? You need to calculate it, but relational database or object relational, they don't have this. And what about this? Jen? You see, we don't have this, but here we have subclass object. What does it mean? We don't have it since our problem domain.
Is this mean the patron table FK?
Yeah. So here, if you need to write it, don't write subclass object. You need to give it the correct name, right? So this one, if here connects to patient, right, you need to write patient. Right. So there's a lot of mistake here, right? So we'll need to write table. Actually, it's not necessary, right? So everything should be the same. That's with participants. Then here should be patient, right? Patient, capitalize it. So patient. They become association, right? And because we know that object relational has no inheritance, right? So no inheritance. So convert it, right? Since inheritance is a one-to-one, right? And if, because here we know that participants has many subclasses, so means that participant is many, you could be doctor, could be something, right? And so it's going to see patient, right? Patient here, patient. Any. So tell me that patient. How can we see the attributes of patient? Here, that's the inheritance. So tell me the attributes of patient. It's a very easy question. Tell me the attributes of patient.
Amount.
How many attributes that a patient should have?
Two.
Yes, the inheritance. That is inheritance, inheritance. Joy. How many attributes that patient should have? So everybody see that, some students knows nothing. It's too easy. Question is too easy. Yeah, I know. So a lot of students knows that, right? So patient, inherit from participant. So patient should have all of that. So we know patient need to have everything, included self. The amounts and insurance carrier, all right? And we know that so amongst insurance carrier, but the methods we cannot convert it. And this one attribute, all right, we have already know that. And that's the relationship, right? So that means that here patient has a relationship, with appointments and symptom, all right? And inherit from participant, of course, So it's all this relationship. So this table, right? So here, this table. So whatever you can see that here we have symptom, we have appointments. It says APPS, that's not correct. It should be the same, right? So appointments, symptom, primary, not primary. It says this participant. So participants, appointments, symptom. All right, and here you can see multiple value. Multiple value. All right, so insurance carrier, this one, so it can have multiple value, right? Insurance carrier is many insurance carrier, right? And primary insurance carrier. And also, you can see primary insurance carrier. Where does this come from? Denver, do you understand the primary insurance carrier? Mental? Primary insurance carrier. Here, primary insurance carrier. Where does it come from? If you notice, then wanting to convert to relational database become very simple. Do you understand it? Please answer. Primary insurance carrier.
One too many.
where does primary insurance carrier come from? We wanted to convert, all right? So now here, primary insurance carrier. Dance. Who can answer this? Kevin?
The reflexive line. In the right side, the reflex line.
Yeah, reflexive. That's the role, all right? So reflexive.
Yes.
So here, it means primary insurance carrier, and we can see the attribute primary insurance carrier. But if there's a reflexive, right, that's the role, right, role. So last time we said if that's employee could be supervisor, right, or worker, right. So we need to identify that. So we still need to address, all right, enumerate that, or we address that's a two role, all right.
Yes. Yes.
And also, that's the value. So it means that if we have the role, so here is the role, all right. Role, then we need to map, to patient. So this patient is a role, all right. Primary insurance carrier, and this 0 to many. And so here, that's patient and symptom, their relationship, of course, patient has many symptom. Symptom, can occur in many patients. It's many to many. But we know that if it's many to many, usually we are going to have an association class, all right? But here, we don't see that. If we transfer to association class, oops, here. It means we don't need to do this because they are the same. And here we don't see that. Actually, no, you may see an association class. And here, everything, we map here. So symptom. And for the symptom itself, we have patient, right? Patient. And appointments, we have patient, right? So you can see patient. But, you need to know that it should be have exactly the same name of that, right? And also, yeah, you're going to see reflexive, but we put inside is a patient, right? Okay. So what I just said is all this. Single value, multiple value. So multiple value is a repeating group, right? So if our problem domain is problem domain course, we have a course and a course name and teacher, right? So it's a repeating group. So a teacher can teach many courses, right? Teacher teach many courses. So object relational database, if our problem domain here, you can only see one class, but apparently, the course will be taught by many, or probably many courses by one teacher. Sometimes two teachers teach one course, but depends on our situation, right? And this one, it says map repeating group of attribute to a new table. So this is repeating the customize many address, right? A new table and creates one to many association from original to a new one. So we create address, for example, create address, right? So address, but customer. So customer should reverse it. But customize many address, right? Many address. So here, then we extract that. So mapping repeating group of attribute to a new table. Customer, right, is going to new a table of address because address is a repeating group, right? And then you have the multiplicity to describe the relationship. It's one to many, and here you can see that if it's relational database, then you don't see this connection, right? It's only use key, so that's difference. Right, so here it is similar. And the others, right, we have already described in the mapping, right? So when we describe multiple inheritance, we change to single inheritance like that. And then one of the inheritance become association, right? And here it says, you can see person, patient, right? It says add a column to the table represents subclass that would contain object ID of the instance stored in the table to represent the superclass. So yes, superclass is a person, right? Represent here. So object relational database, then the person has the patient, and patient, right, this person. But if they come from multiple inheritance, and then we need to use exclusive. So yeah, almost the same as like last time. The car and previous car and boat, but that's it's quite difficult. But if you know how to map, right, to object relational database, then you should be easier. You know, it could be easier to understand how to convert it to relational database. But I think we have run out of time. Any question? So I'll give you a couple minutes because TA will give you a quiz. Then it is an option, right? You can choose to stay to take the exam or leave, whatever you like, right? Next, we will continue this issue.
So if you don't want to get an extra point, you can left. And the quiz, if you answer with English, you will get 10% extra credit. So you can try your best to use English to answer the question. And